In the previous video, we talked about the powerful techniques that this beautiful method, which is mass spectroscopy, can tell. And we introduced you how to calculate the atomic mass by the mass spectrometry in addition to the molecular mass, and then how to determine the number of carbon atoms in your compound using this beautiful technique. And now let's talk about the last thing, which is how can I determine the type or the presence of halogen in my compound. So let's go and check this out. Let's start with the bromine. And generally speaking, bromine element has two isotopes. It has 79, Br79 and Br81. And you can see that these two isotopes in nature, they have a difference. Like this is M plus and this is M plus 2. So the difference between the two values in here is 2 neutrons. So if you look at the graph in here, which is the mass spectrum, this is M per E, mass per electron, and this is the natural abundance. If we just come and look at the two guys in here, the two peaks, you notice that you have 162 and 164. Okay, so in general, you can deduce that you have a halogen in which you have 162 and 164. This is M plus 2 because you have a difference of 2 neutrons. But how can I determine whether I have a bromine or a chlorine? The rule says if you have two peaks that are in the same heights or the same relative abundance, then the halogen that you have is Br. So the Br isotopes, they have a ratio between each other, which is 1 to 1. How can I determine whether I have a chlorine or not in my compound? Let's go again to this guy in here. The rule says if you have a chlorine in nature contains two isotopes. We have a chlorine 35 and a chlorine 37. In other words, we have M plus and M plus 2 because the difference between them is 2 neutrons. But what about their heights, their ratios, their relative abundances? Put in your mind, chlorine 35 is 3 to 1 in height, which means if you have, let's say, a random compound, let's say just like from my mind, let's say if you have a 100 in here, and this guy is going to be 102, in which you have M and M plus 2. So if we take this in here, it should be like 1/3, okay? If you just like, it's going to be 1/3. So this is a 3 to 1 ratio, okay? So since you have this 3 to 1 ratio, you have a difference of M and M plus 2, M and M plus 2, then definitely you have Cl as a halogen. And now let's start solving some questions. Let's come to this guy in here. The question says, in addition to carbon and hydrogen atoms, each molecule of ketamine contains one atom of each three different elements. These are called heteroatoms. One of these heteroatoms is a halogen. Okay, it could be Cl or Br. Okay. Use the figure in the table to suggest the identity of this halogen and explain your answer. Okay, so how can I explain my answer? First of all, you have to look at the M, okay, and M plus 2. Okay. Let's look, just like have a look at the height in here. It's 133, which means, in other words, the relationship is a 3 to 1. So if you have M and M plus 2, the ratio is a 3 to 1, then definitely the halogen that you have is Cl because their height is 3 to 1.